Before looking at an example of how to work out the area of a parallelogram using the diagonals, it's handy to know where the sum that we use comes from. Firstly, a parallelogram has two diagonal lines inside. We can label them D1 and D2. And where these diagonals meet and cross each other, four angles are created, which are actually two equal pairs. This angle is the same size as that one, and this angle is the same size as that one. And another thing to take note of is that four triangles are created inside the parallelogram by these diagonal lines. We have one triangle here, second triangle here, third one, and on the left we have our fourth triangle. Now we can bring up a slightly altered version of this parallelogram with diagonals labelled slightly differently. Now it turns out that the diagonals of a parallelogram cut each other in half. So at either side of the crossing point we can label the side lengths D1 over 2 and D2 over 2. So we now know the side lengths of each of the four triangles, and this is helpful if we refer to one of the formulas to work out the area of a triangle. Now the area of all four triangles together will be the area of the parallelogram, and this formula is especially helpful if we focus on the angles that we have here. The angle on either side of a straight line is 180 degrees. So whatever size of angle A turns out to be, B will be 180 degrees minus A. And it just so happens that when we're working out the sine of an angle in degrees, the sine of that angle is equal to the sine of 180 degrees minus the angle. So we actually have, it be the case that sine A in our parallelogram is equal to sine B. So using this formula to work out the area of each of these triangles, we can actually use the same interior angle for C each time. And we can also observe that for A and B sides, each triangle inside the parallelogram has exactly the same, D2 by 2 on one side and D1 by 2 on the other side. And this leads us to the following. Each triangle inside the parallelogram can be worked out with this sum. So in fact each triangle is actually of equal size, although they may appear different when you look at them. So multiplying what we have here by 4 will give us the area of the parallelogram. And this is what we get. Multiplying out what we have here using the properties of multiplication gives us this sum, which is what we use to find the area of a parallelogram when we know the diagonals and one of the angles between them at the point where they cross each other. So for our example here, to work out the area, we have a half multiplied by one diagonal, 8, multiplied by another diagonal, 11, multiplied by the sine of one of the angles which we are given, 54 degrees. And when we multiply this all out, we end up with a value of 35.6 meters squared to one decimal place for the area of this parallelogram.